A cast is a type name in parentheses, written in front of a value, and it forces a conversion that would not otherwise happen. The first line is the one you will write most often, and the reason casts exist. Total and count are both integers, so total divided by count is integer division, which throws away the remainder. 9 divided by 2 is 4. And your average is wrong before it is ever assigned. Casting total to double first makes one operand a double. Rule 2 of the usual arithmetic conversions promotes the other, and you get real division. Note where the cast goes, on one operand, inside the expression. Casting the whole thing, double open paren total divided by count, would do the integer division first and then convert the wrong answer, which is a mistake people make constantly. The second line shows what an integer cast actually does to a fractional value. It truncates towards 0, so 3.99 becomes 3, not 4. If you want rounding, that is round or around from math.h, not a cast. Now the judgment. Casts silence the compiler, and that is precisely why they are dangerous. When you write a cast, you are telling the compiler, I have thought about this conversion, I know it loses information or changes interpretation, and I want it anyway. That is a legitimate thing to say. The problem is that it is also exactly what you type when you have not thought about it at all and just want the warning to stop. Those two situations produce identical source code, and the reviewer cannot tell them apart. So here is a test that works well in practice. Write the cast only when you can say in one sentence why it is safe. This value came from strlen, so it cannot exceed int max here. Fine. This is a network byte I know is under 128. Fine. If the sentence does not come, the answer is not a cast. It is fixing the types, so the conversion is not needed. And be particularly suspicious of a cast that appeared in a commit whose message says fix warning. That is a bug with a receipt attached. One specific rule to finish on, because you will see the wrong version everywhere. Do not cast the result of malloc in C. Malloc returns a void star, and in C a void star converts to any object pointer type automatically with no cast, so the cast is pure noise. Worse, it is harmful noise. If you forget to include stdlib.h, then in old C the compiler assumes malloc returns an int, and the cast papers straight over the mismatch between an int and a pointer, which on a 64-bit machine truncates your address to 32 bits and hands you a pointer into nowhere. Without the cast, the compiler complains and you fix the include. This is one of the genuine differences from C++, where the cast is required because C++ has no implicit conversion from void start, so C++ programmers write it out of habit, and it propagates. While you are looking at that first line, note the other idiom in it, sizeof*p rather than sizeof*int. Now the allocation is correct by construction, and it stays correct if you ever change what p points to.